You also need to be familiar with the way elements are classified in the periodic table. Okay, so let's look at some of those classifications. One way you can classify elements is whether they are main or representative or transition. Okay, so main, another word for main, when I say or representative, that means it doesn't mean that they're two different things. It's the same thing. Main and representative is the same thing. So either main elements or transition elements. The main or representative elements are in the columns that are labeled with the A after the number. So 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. So that's actually columns 1, 2, and 13 through 18 in your periodic table. Those are the A groups, the main groups. Okay, so uh, in some periodic tables, you may see them labeled using a Roman numeral. So this is 1A, this is Roman numeral 2A, and this is Roman numeral 3A, and so on. Okay, so for example, sodium we say belongs to group 1A, so it's a main group element. Okay, it's a representative element. Sulfur belongs to group 6A, so that's a representative element. It belongs to an A group. Okay, now the transition elements are those that are found in columns 3 to 12. So here's columns 3 to 12. And you'll notice the labeling of this goes from 3B, 4B, 5B, 6B, 7B. And there are three columns that are labeled 8B, and then you have a 1B and a 2B. Okay, so these columns of elements are referred to as the transition elements. And in some periodic tables, they're labeled using Roman numerals, so 3B, 4B, 5B, and so on. Okay. There's a group of elements uh, called inner transition elements. If you look at your periodic table, okay, let's go back here. You'll notice when you go to right here from barium, it's number 56, lanthanum 57, it skips from 57 to 72. What's actually happened there is that this lanthanum is the beginning of a series and the rest of that series has been pulled out of that table to make it shorter. So the 58 through 71, okay, which follows lanthanum, which follows number 57, okay, this is 57 right here, and then 72. So 58 through 71 actually is right here in between the two. So 58 through 71 actually belongs to this same period here. So it's a period 1, 2, 3, 4, 5, 6. So the Lanthanide series, the series of elements that follows lanthanum, actually belongs to period 6. Okay? You refer to those as the inner transition elements, the lanthanides. They follow lanthanum right here. So this series right here, 58 to 71, actually belongs there. So those are known as the inner transition elements. The actinides, the group that follows actinium right here in period 7, also are considered as inner transition elements. So this series of elements, there's 14 of them, okay, from between 89 and 104. Those are the actinide series. So lanthanides are part of period 6, and the actinides are part of period 7. Got it? All right. There's a few more names you need to know. All the metals belonging to group 1A, okay, all the elements belong to group 1A are known as the alkali metals. Sorry. So 1A are alkali metals. Now hydrogen is not a metal, so we don't refer to that as an alkali metal. Although in very adverse conditions like in Jupiter, it's been observed to behave like a metal. Well, it's predicted to behave like a metal. 2A are known as the alkaline earth metals. So the alkaline earth metals are beryllium, magnesium, calcium, strontium, barium. Okay. In 7A, this one right here, you have the halogens. Okay, so the halogens are fluorine, chlorine, bromine, iodine, and the bottom one there's astatine. And then group 8A, you need to be familiar with those elements. They're called the noble gases: helium, neon, argon, krypton, xenon, and radon. 6A are known as the chalcogens. Okay, so oxygen, sulfur, selenium, tellurium, polonium. Okay, so those are some groupings that you need to be familiar with. Now, the metals, the elements can also be classified as either metals, nonmetals, or metalloids. The metallic elements, okay, those are the elements that if you find them in nature as pure elements, then you'll see them in the periodic table. They're listed on the left side of the periodic table. Okay, so you'll see your metals over here on the left. Okay. And on the right side of the periodic table, you have your nonmetals. Now, what makes something a metal? Characteristics of a metal are, you've seen a metal, right? You know what a metal looks like. They're shiny, okay? They're malleable. What does malleable mean? It comes from the same root word as the word mallet, or hammer. Okay, so a malleable material is something that you can hammer into thin sheets. So a piece of metal that you might have at home that comes in thin sheets would be aluminum foil. You can see aluminum right here is a metal. Ductile means you can draw it out into a thin wire. Okay, so this can malleable, can be hammered into thin sheets. Ductile means you can draw out into a thin wire. And what's an example of a metal that you've seen that's being used as a wire? Copper metal. Okay, so copper metal is used for your electrical wires. In fact, the reason you use it is because metals are also good electrical conductors. Okay, so you don't want to stick a wire into an electrical socket because you'll get yourself electrocuted. The wire is a good electrical conductor. Metals are also good heat conductors, and so that's why if you have a metallic ladle, you want to put a wooden handle on it because that metal part conducts heat very well. Okay, now somewhere between the metals and nonmetals, you'll find the metalloids. So if you want to know where the boundary is between the metals and the nonmetals, just look for these metalloids. These are elements that have characteristics that we'll find later. Their behavior is somewhere in between those of metals and nonmetals. So boron right here is a metalloid. Silicon, germanium. Okay, so you can see the staircase line right here. Okay, so arsenic and antimony, tellurium, polonium. Astatine might also be considered one. Aluminum is really bordering on being somewhat of a metalloid, but typically we consider that as a metal. Okay, so everything to upper right hand side would like carbon, phosphorus, those are all nonmetals. Hydrogen also is considered a nonmetal. Okay. All right, so given all of that, let's end. Let's one more group. The transition elements, because all of the transition elements, if you look at your periodic table, all the transition elements over here, these are all metals, so they're also referred to as transition metals. Okay. Now, metals. Now, there are some metals that go past the transition element. Just past the transition elements, you have gallium, indium, tin, thallium, lead, and bismuth. These elements right here, these 6 elements, these are referred to as the post-transition metals. They come right after the transition metals. But they're actually not transition metals. They are representative elements. They're main group elements. So it's between the transition metals and the metalloids, you will find your post-transition elements or post-transition metals. Okay, so Let's look at this question right here. Which element would be a good electrical conductor? Copper, germanium, or krypton? Answer is copper. Why copper? Copper is a metal. Okay. Germanium is metalloid. Okay. It's used in semiconductors. So semiconductors are not quite as good as conductors for conducting electricity. And then krypton, of course, here is a nonmetal.